Let's come to the rule number 5. In this, q is equal to x time v. Okay, v is the function of x, and we see if non-homogeneous equation contain qx is equal to xv, then how we are going to solve that non-homogeneous linear differential equation with constant coefficients. In that case, particular integral 1 over fd xv is equal to x outside operating with inverse operator of fd v plus derivation of fd 1 over fd with respect to d, okay, operating with this operator v, which is the function of x. So this is the rule number 5. So I'm gonna solve with the rule, with this rule, some problem. Okay, let's take a few problems in order to illustrate this rule, right? So first problem is d square minus 2d plus 1 y equal to x sin x. Okay, so complementary solution here would be, because it would be having two roots, 1 and 1 repeated root, so complementary solution is c1 e raised to power x plus c2 x e raised to power x, right? Now let us try to find out the particular integral. So yp would be equal to 1 over d square minus 2d plus 1 x sin x. So see here, v is equal to sin x, right? Now yp, if I now use the rule of 5, right? So we know 1 over fd xv is equal to 1 over x outside 1 over d square minus 2d plus 1, right? And now vx plus differentiation of this derivative 1 by d square minus 2d plus 1 sin x, right? So writing it as it is, 1 over d square minus 2d plus 1 sin x, and now differentiate this. So we know quotient rule, squaring the denominator, then denominator as it is into differentiation of numerator, which is 1, so 0. So now minus 1 as it is, differentiation of denominator, which is 2d minus 2. Okay, so minus I'm writing here, so minus I'm writing here. So this is the derivation of above operator, right? Now since we can apply rule 5, rule 4 now, because sorry, rule 2, 1 over, when you are having sin x inside the inverse operator, then we have to replace d square by minus a square. So here we are going to replace d square by minus 1 square, which is equal to minus 1. Okay, so we can write minus 1 minus 2 plus 1, right? Sin x minus 2d minus 2 divided by minus 1 2d plus 1 whole square sin x, right? So 1 1 cancel, and you will be having x by 2 minus x by 2 1 by d sin x minus 2d minus 2 divided by, so here also 1 cancel, so it would be 4d square, okay, on sin x. So now minus x by 2, so 1 by d we know it stands for integration, so integration of sin x is equal to minus cos x, right, minus so now instead of d square you can write minus 1, okay, because again by rule number 2, okay, so 2d minus 2, okay, whenever you are using rules, okay, whichever rule you are using, you can write that name of the or that rule number, right, so it is minus 4 into sin x, rule 2, right, rule 2 in order to find out in particular integral, okay. So now it is minus plus x by 2, and it would be cos x minus plus again 2 cancel, so you are having 1 over 4 d minus 1 sin x, so x by 2 cos x plus 1 by 4 differentiation will be making cos x minus 1 by 4 sin x, right, which is the particular integral in this case, okay. So which is the solution of given differential equation. We just okay, we just forgot to cancel this also, so it is 2, right, so it is 2, okay, so this is the solution, so it is equal to x by 2 cos x plus, or you can club this cos x, right, you can write it as x plus 1 divided by 2 cos x minus half sin x, right, so therefore particular solution is this, and complete solution is yc plus yp, yc was equal to c1 e raised to power x plus c2 x e raised to power x. Now particular solution is x plus 1 divided by 2 cos x minus half sin x, right, so this is the solution of given differential equation, okay. One more problem we are going to solve, okay, so problem is y double dash plus y is equal to x ex cos 2x, fine. So symbolic form, in symbolic form we can write it as d square plus 1 y equal to x ex cos 2x, right. Now auxiliary equation is d square plus 1 equal to 0, this implies roots are plus minus iota, therefore complementary solution is c1 cos x plus c2 sin x. Now particular solution is equal to 1 over d square plus 1 x ex cos 2x. So we will be using firstly rule 2, okay, sorry, rule 4, right. So in rule 4 we will be taking it out exponential x, because rule 4 says f of d exponential ax v is equal to exponential function outside and replace f by d plus f of replace f of d by f of d plus a and inside v. Okay, right? So it would be d would be replaced by d plus 1 whole square plus 1, right? And inside you will be having this and this, x into cos 2x by rule 4. Okay, so exponential x d square plus 2d plus 1 plus, so it would be 2x 2 cos 2x. Now again, now we will be using rule. So it is x into something, so it is kind of x into v now, so we will have to apply rule 5. Okay, so applying rule 5 now, we get x outside the operator, and inside you will be having d square plus 2d plus 2 into cos of 2x plus derivation of the operator d square plus 2d plus 2 and cos 2x here, right? So it is ex now, since now by rule 2, okay, we are going to replace d square by minus 2 square, right? And in second part we are going to differentiate, so write as it is. Okay, later on in next step we will be changing it, d square plus 2d plus 2 cos 2x plus, now differentiate it, it would be d square plus 2d plus 2 whole square, and above it would be minus 2d plus 2 by quotient rule, right? So now we are going to use rule 2, okay, in which trigonometric function, whatever is inside the trigonometric function, like here we are having 2x, so we are going to replace d square by minus a square or minus 2 square, right? So it would be x, so d square would be written minus 2 square plus 2d plus 2. Okay, so cos 2x minus, okay, so I'm writing minus outside, so 2d plus 2 upon minus 2 square plus 2d plus 2 whole square cos 2x. Okay, so now exponential x divided by, this is minus 4 2, so you would be having 2 minus 2, right, into cos 2x minus 2d plus 2 divided by, again it would be 2d minus 2 whole square cos 2x, right? So now you do what? Okay, you take 2 and 2 common, okay, from here, so we are writing it outside of bracket ex by 2. Okay, so inside you will be having 1 over d minus 1 cos 2x. So from here also, if you take 2 outside of this bracket, you will be having 4 here, then 2 and 2 cancel 2, okay, it would be 4 here, so 2 gets cancelled with 4, so we are having 2 here now, so it would be taken out, so you will be having this d minus 1 here, and in denominator d minus 1, sorry, this is d plus 1, okay, and denominator d minus 1 whole square and cos 2x. So in this way it is becoming x. So now in order to make it square, we are going to multiply and divide with d plus 1. When you multiply with the denominator by d plus 1, it would become d square minus 1 cos 2x minus, now open up the square, so it would be d square minus 2d plus 1 cos 2 x. Okay, now exponential x divided by 2 x d plus 1 divided by minus 4 minus 1. Okay, again by rule number 4 it would have been minus 2 square, so which is minus 4, right? So 2x minus d plus 1 divided by minus 4. Okay, and this, right? So it would be minus 2d minus 2d minus 3. Okay, so minus 3 I'm taking common, so it would be plus, so we can write 2d plus 3 here. Okay, and cos 2x. Now exponential x by 2 and here you will be having x by minus 5 and d plus 1 cos 2x. Okay, plus, now we are going to multiply and divide 2d minus 3. So here it would be 4d square minus 9. Okay, so now x by 2 minus 5. So operating with d, we get minus 2 cos sine. Okay, this is nothing but differentiation of cos 2x. So cos 2x की differentiation कितनी हो जाएगी? minus 2 sine 2x, right, plus cos 2x. And here you are going to use rule 2 again, because we are having d square here. So denominator as it is, numerator as it is, 2d minus 3 upon minus 4 into 2 square. Okay, minus 9 cos 2x. Then it would become exponential x divided by 2 minus x by 5. Okay, if I take it inside, we would be having 2 sin x, 2 sin 2x minus cos 2x, right, plus, so it would be minus 16 minus 9, so it is 125 in negative, right? So numerator would be 2d square, multiplying this numerator, okay, with each other, we get 2d square minus 3d plus 2d, which is minus 1d and minus 3. Okay, cos 2x. So in this way it would become x by 5 2 sin 2x minus cos 2x minus 1 by 25. So this is 2 times d square. If I differentiate cos 2x 2 times, we get cos 2x again with negative sign and with this constant. Okay, square of this constant, because we are differentiating 2 times. So it would be minus 4 cos 2x, right? And then you differentiate it 1 time, we get minus plus and 2 sin 2x. Okay, because differentiation of cos 2x is equal to minus sin x, right? Then minus 3 cos 2x. Okay, it would be 18. Okay, sorry, it would be 8, because this 2 I just messed this 2 here. Okay, so 2 into 4, which is 8. Okay, so minus 8 to x. So close this now and simplify it. On simplifying we get ex divided by 2 xy5 xy5 2 sin x 2x minus cos 2x minus 1 over 25. If I take it common, so we get 1 over 25, 8 and 3, 11 cos 2x minus 2 sin 2x. Okay, so this is your particular integral, right? This is your particular integral. Now this can be also simplified little bit more. Okay, little bit more simplification is possible in this case again. So like we can bring together sin 2x and this sin 2x. Okay, so if I write it as so I'm just directly doing this. Okay, so this is 2 sin 2x. Okay, so 2 by 25, right? And this is 2x divided by 2x divided by 5, right? So it would become 10x. Okay, 10x minus 2 divided by 25 into sin 2x. Okay, plus now clubbing these two terms together we get 11 minus 5x divided by 25. Okay, into cos 2x, right? So now multiplying inside with exponential by 2 we get, so 2 to cancel in first term, so 5x minus 1 divided by 25 ex sin 2x, and in second term nothing will be cancelling out, and we will be having 11 minus 5x divided by 50 exponential cos 2x. So this is the particular integral. And now if you want to find out complete solution, we will have to write together complementary solution and particular solution. So complementary solution was c1 cos x plus c2 sin x, and particular solution is 5x minus 1 divided by 25 exponential sin 2x plus 11 minus 5x divided by 50 into exponential cos 2x. So this is the required solution of given differential equation, right? So now I'm gonna give you an exercise. Okay, I hope you will do it by yourself. So problem is this: double derivative of y with respect to x dx square minus 2 dy dx plus y equal to x ex sin x. Okay, so solve it. Okay, so this is a problem you are going to solve by yourself. Okay, I hope you will do this. So with this we complete section V, and in next video we are going to start another section, that is section 3. Okay, thank you.